Okay, I thought I'd work a few problems here just to kind of have some more out here for you to use in case you get stuck on your homework. Let's start with 57. 57 says find the polynomial function that has the given zeros. And there are many correct answers. Okay, we'll talk about why there are many correct answers. They give you 2, 4 plus the square root of 5, and 4 minus the square root of 5. Now, one of the things I'm going to check for when I see this list is if I see any conjugates on here, things like 4 plus square root of 5, I know the other one has to be there too. If you look back in your section, you'll see that they always occur in pairs. Okay, so if I want to find this, one thing I can use is the idea of, I'm looking for the real zeros on polynomial functions, page 107. If I want to write a function, if these are the zeros, I know that this, like the answer 2, how did I get the answer 2? There was a factor, x minus 2, that I set equal to 0 to solve for 2. Likewise, there was a something x minus 4 plus square roots of 5 and x minus 4 minus square roots of 5. Now that's the polynomial function in factored form. You can multiply it out. I'm not going to make you. You could do it. It would be a good practice just to maybe practice some skills in, distributing. I guess, you know what, it might be a good idea here if I did it just to make sure you could mess with these conjugates over here. Let's say I'm going to multiply this out and I'm going to distribute, I'm going to have to, kind of group things together so I do 2 factors at a time. I'm going to start with these here. I'm going to show you how nicely they clean up. X times x is x squared. X times negative 4 minus square root of 5 is going to be negative 4. Let me go, I tell you what, before I distribute this, let me do something to this to make this a little less confusing, because the whole thing is going to get confusing if I don't do this. Let me see if I can't get rid of some of the junk I put on this paper. Okay, one thing I'm going to do here, because this is going to get really be a pain here, is that I'm going to go ahead and distribute this minus sign here, x minus 4 minus square root of 5, and then over here it's x minus 4 plus square root of 5, okay? So if I wanted to multiply this out, I would have x minus 2, and then I'd have to go x squared minus 4x plus square root of 5x. Okay, now that was just multiplying the x times all that. Now I'm going to multiply this negative 4. Negative 4x. Negative 4 times negative 4 is a positive 16. Negative 4 times square root of 5 would be negative 4 square roots of 5. Okay, so now I did that one. I still got one more term to multiply here, the minus square root of 5. Negative square root of 5 times x is a negative square root of 5x. Negative square root of 5 times a negative 4 would be a positive 4 square roots of 5. And negative square root of 5 times a positive square root of 5 would be a minus, that would be square root of 25, which is a 5. Now, there's going to be some stuff cancel out here. So let's kind of see what all happens here. I have this minus 4 square roots of 5. And plus 4 square roots of 5 that cancels out. I have a plus square root of 5x and a minus square root of 5x. So if I look what's left, I have x minus 2. Now that first factor still there. Then I have x squared right here. Okay, wrote it down. I got minus 4x, and minus 4x is minus 8x. Write those out. And I have a plus 16 and a minus 5, which would be a plus 11. Okay, so that's now looks like this. And if I want to multiply it out, I'd get x cubed minus 8x squared plus 11x, and then minus 2x squared when I start distributing the negative 2, plus 16x minus 22. And if I clean that up, let's see, that's x cubed, and I've got minus 8x squared minus 2x squared, so that would be minus 10x squared. 11x plus 16x would be 27x, and then you've got this minus 22. Now that would be the most basic function. The reason there are many answers is I could multiply this through by any constant term. Like up here when I set my factors up, I could have put a 2 out front, or I could have put a 3 out front, or a 4, anything I wanted to, any constant I wanted to, I could have put out front and multiplied that through. Most people choose not to do that because it's just another number you got to multiply by instead of just having your, this is just a little simpler to distribute, so we tend not to do that. But any constant number could have been put out front, and I would have had the same zeros, the same answers, the same x-intercepts. But this would be like what most people probably would have gotten if they worked that problem. Okay, let's look at problem 63. We're supposed to find a polynomial function with the given zeros, multiplicities, and degree. And so it says, again, there are many correct answers because whenever I write these factors down like I'm going to do here in a minute, I could put a constant number out in front of them, and I'd have a different equation, but it would still, have the same zeros. I notice this is a third degree. That means at the most I want x cubed. I don't want to get x fourth out of this. So let's see what they've given us here. Let's start breaking this apart a little bit at a time because that's what you kind of have to do here. If I have a 0 of -1, doesn't that mean that somewhere I had a factor that said x plus 1 equals 0, and then I would subtract my 1 and get x is -1? That factor would have been x minus -1 or x plus 1. If you remember when we write our factors, it's always x minus the number that we get as our answer, so it would be a -1, making it x plus 1 as a factor. They tell me, okay, so I'm going to write y equal here. They tell me it has a multiplicity of 2. That means that factor appeared twice. I can write it as x plus 1 times x plus 1, or I could just put a square on it, and that would be the shorter way to write it. Okay, so now I got another 0. They tell me this 0 is -2, multiplicity of 1. That means this factor occurred once. If I think about my factors, it's always x minus the number that I get as my answer, -2 is equal to 0. That would be x plus 2 as my factor. So I'm going to write that down as x plus 2. So we've taken care of this. We've taken care of this. If you look now, we would get an x cubed out of this when I multiplied it, so we've got the degree of 3. Now, this is an odd degree, right? It's x cubed is an odd exponent. If I plug in a negative number, because I don't have anything out front, this should be a bigger negative number, which means it would be falling over here on the left side, but they want it rising. How am I going to get it to change? Well, remember, if I put a -1 in there, a -100 in there, I would get a big negative number, which would be why I drew this green arrow going down. To get it to go up, all I'd have to do is put a constant out front that would have a negative sign that would change that large negative number to a large positive number. So just put something out front like a -2 or a negative whatever. It can just be a negative number out front. It could even be a -1/2 or just a negative sign. But anything out front would work. Now if you think about it, when I put in a positive number, like let's say 1,000, and I cubed it, I'd get a very large positive number. So the way this was written before, it would be going up. By adding this -2, I've now switched it to going down and falling to the right, which the instructions told me to do also. So here's an example of an answer. That constant right there could be any number you want it to be. It could even be the invisible 1 if all you want to do is make it go down and you don't want to change any of your, if you just want to make it the most basic thing it could be. This would be, this would be the minimum you'd have to write for this equation to have something that would work out correctly.